Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. And good morning. Welcome to Mathematics 2 AM025. Okay. Topic 1, differentiation. At the end of this lesson, students should be able to state limits of a function fx as x approach a given value a, limit fx when x approach a equals to L. Second is state the basic properties of limit. (1.1) Limits and derivative. Definitions of limits. A function fx is said to approach a constant L as a limit when x approach a as below. So here we have limit fx when x approach a equals to L. We are interested not in the value of fx when x equals to a, but in the behavior of fx as x come closer and closer to a. Okay, what does it mean is, it means that when x get closer to a but x does not equals to a, fx gets closer to L, read as limits of f as x approaches a is L. So we have three different notations. The first one is this one, where x approach a from the right. The second one is this one, where x approach a from the left. And the third one is x approach a. What does it mean? It means x approaches a from both sides. The limit of a function can be evaluated by using two different methods. First is intuitive method, and B is by using properties. So for intuitive methods, computations of limit. So first one, a table of values of x versus fx is drawn up. Second, the values of fx are observed to see whether they approach a particular values. The keyword is observe. Step 1, select several values of x close enough to a. Step 2, observe the patterns of corresponding fx values. And step 3, then guess the values of fx when x is approaching a. Example 1, find limit x squared plus 1 when x approaches 0. To solve these questions, so we have here, so x approaches 0 from the left, and this one we have x approaches 0 from the right. So we have a table here, and we have different value of x, which are from -1 to 1. What do we do with this value is, we substitute this value into the f function. For instance here, when our x equals to -1, so what do we have here is, we have f minus 1 equals to -1 square plus 1. And this one is 2. So we have 2 here, so therefore we write 2 here. So next one is, when x is minus 0.5, we have 1.25. When our x is minus 0.25, we have 1.0625. And when our x is minus 0.001, our fx is 1.0000 how many zero? 5, 0, 1. When our x equals to 0, our f0 is 1. And when our x is 0 0.001, our values is 1.000001. When x is 0 0.25, this one is 1.0625. And when our x is 0 0.5, we have this one is 1.25. And when x equals to 1, we have this one is 2. Okay. So what happened here, you see these values. So we have 2, 1.25, 1.0625, 1.000001. Okay, these values on the left. And we see the values from the right. So this one we have 2. And next one we have 1.25. Next one we have 1.0625. Next one we have 1.000001. So what happened to this value is, this value is getting smaller and smaller, and they approach 1 here. Okay. So this one is based on the calculations. What happens if we have a graph? So we may have a graph something like this one. So this one is a quadratic graph. So where we have fx equals to x squared plus 1. Right? So what happened here? So this one is 1. This one is 1. So what happened here, around here, is when your x approaches 0, the values of y, or the limit, approach 1. So therefore, for these questions, for this one, limit x squared plus 1, when x approaches 0, the answer is 1. Right? Now we will calculate the limit by using properties. So for the first property, what we have here is this one. If fx equals to c, where c is a constant, limit fx when x approach a equals to limit c when x approach a, which is a c. So example 2 here, limit 5 when x approach 3. So since 5 is a constant, therefore the limit is 5. So for property number 2, we have if fx equals to x, then limit x when x approaches a equals to a. So example here we have limit x when x approach to 3, and the answer is straight away 3. That is property number 2. For property number 3, if fx equals to x power of n, where n is a positive integer, where n is greater than 0, then limit xn or x power of n when x approaches a equals to a power of n. So we have example 4 here. So we have limit x power of 3 when x approaches 2. So how do we solve this one? So here we have 2 power of 3, and this one is 8. That is example 4. For properties number 4, what do we have here? We have limit when fx plus or minus gx, where we have two different functions, and these two functions, either we add these two functions or we subtract these two functions when x approaches a. So we can write this one as limit for fx when x approaches a plus or minus limit for gx when x approaches a. So for example 5 here, we have limit x power of 5 minus 10 when x approaches minus 1. So by using property number 4, we can write this one as limit for x5 when x approaches minus 1 minus limit x approaches minus 1, and this one is 10. Okay, so next step we substitute. So this one we have negative 1 power of 5, right? Then we minus 10. Okay, and this one, upon simplifications, we will have the final answer should be minus 11. That is property number 4. Property number 5, what do we have here is limit, and we have two functions, and these functions are multiply each other. In this case, we have fx multiplied by gx when x approaches a. So here we can write limit fx when x approaches a multiplied by limit gx when x approaches a. So example 6 here, what we have here is limit x squared minus 5, and then we have x plus 1 when x approaches 4. So what we can do here is we can write limit. So we have x squared minus 5. So when x approach 4, then we multiply, or we put dot there, we can write limit. Our next function is, we need to put bracket here. Okay, so we have, so x plus 1 when x approach 4, right? So next step, we substitute the values of x. So what do we have here is we have 4 squared minus 5 dot multiply by 4 plus 1. So 4 plus 1, right? And if you simplify this one, we will have, I think final answer should be 55. That is property number 5. Alright, so next property is property number 6 here. If c is a constant, then limit c multiplied by fx, x approaches a. So we can write the c here at the front because of c is a constant. So for example 7 here, so we have limit 5x power of 3 when x approaches 10. So this one we can write this straight away. So I write 5 because 5 is constant. Then I can write limit x cubed when x approaches 10. Okay, and next step we substitute the values of x. So we have 5, and then we have 10 power of 3, and the final answer should be 5,000. That is property number 6. So for property number 7, so what do we have here is when limit fx over gx when x approaches a, we can write this one as limit for fx when x approaches a over limits gx when x approaches a. Conditions are provided that limit gx when x approaches a does not equals to 0. So for example 8 here, so we have this one. Limit x over x squared plus 10 when x approaches minus 5. So this one, I can rewrite this one as limit x when x approaches minus 5 over limit x squared plus 10 when x approach minus 5. Okay. So next step we substitute. So if we substitute, what do we have is, so this one, what do we have is, for the numerator we have minus 5 over, so for denominator we will have minus 5 square plus 10. And final answer should be minus 1 over 7. This is property number 7. And for the final property here, what do we have here is, if f is a polynomial function, then limit fx when x approaches a equals to fa. So basically we substitute x equals to a into our polynomial. And for this one, for example 9, so we have limit 3x squared minus 4x plus 10 when x approaches minus 2. This one equals to 3 minus 2 square minus 4 minus 2 plus 10. And for this one, the final answer should be 30. Right, correct, 30 minus 2 square for 12. 12 plus 8 is 20 plus 10, 30. Alright, that is example 9. Now we look at example 10. Find the limits of question A. We have limit 1 over x squared when x approaches 1. So how do you solve this one? We just substitute the value of x equals to 1. So we have 1 over 1 squared, and final answer is 1. Then example A. Example B, we have limit 3x plus 4 over x minus 2 when x approaches 3. So what we do is we substitute. So we have 3 plus 4 over 3 minus 2. And final answer is 13. This is example B. And finally, example C. What do we have here? We have limit x squared minus x minus 4 over x squared plus 2x plus 1 when x approaches minus 2. So again, we substitute x equals to minus 2 into the function. So we have minus 2 square minus 2 minus 4 over minus 2 square plus 2 minus 2 first one. And final answer should be 2. Done lecture 1.